Welcome back to Data Science Sydney, the ever-expanding meetup that is now happening almost weekly. Who went to my presentation a couple of weeks ago? Who walked out in disgust before it finished? I'm sure some of you did. That one's going to be repeated actually, because the plan was to make a video of it, and for various administrative reasons we couldn't quite manage it despite the best efforts of our wonderful sponsors N-World and Greg Pearl over there, more on him later, who makes the videos possible. So yet another reminder that all the presentations that you're seeing, and so I think about 2 years worth of presentations so far, are available on the Data Science Sydney YouTube channel. So tell your friends, if anyone who missed the meetup that you thought was great, the video is still available. So yeah, Data Science Sydney is becoming ubiquitous. We've got a new management and strategy stream launched. So I presented at the first one. I will not be presenting at the next one, but we're going to have a range of high-profile managerial strategic presenters and panels to discuss the real issues in the industry, as well as related initiatives. I'm also pleased to say that there is another new stream coming, almost like a complement to that stream. Where's Ian Hansel? Ian Hansel over there, who is doing lots of interesting things in the data science scene in Sydney, is also taking on the mantle of running a new stream next year, which will be the practice and strategy stream. So this will be the stream where you, beginning and intermediate data scientists, are going to be given what I hope is very useful advice on how to survive and thrive as a data scientist, how to structure your careers, how to maneuver the politics and culture of large organizations, and how to be a data science success. So Ian will be taking care of that, and of course we'll have our usual stack of sponsored events and so forth. In fact, the aim is to have more than one Data Science Sydney event per week next year. As always, we start by thanking our sponsors and helpers and everybody who makes Data Science Sydney possible. And of course we start with CBA, because these amazing premises are made possible by them, as is the fine food and drink that many of you are still munching very quietly. I'm not hearing any munching, I'm just seeing it. So a big thanks to CBA for continuing to support Data Science Sydney, and a big thanks to the CBA people who are such an integral part of this. Where's Kevin? Hey Kevin, thank you so much for making this possible, Kevin, who's basically the point man for this entire exercise. And Perry, where's Perry? Perry here today? Well, thanks Kevin, thanks Perry. Thanks also to the various CBA folks who made this all happen in the first place. And thanks to the other organizations who were hosts of Data Science Sydney previously, Vodafone and Atlassian, who allowed Data Science Sydney to grow. As you can see, we are now, well, we're bursting at the seams, right? We're pretty much, you know, if everyone was standing upside down, we'd probably be full house. So a big thanks to our hosts. Once again, a big thanks to Greg Pearl, recruiter extraordinaire and supporter of this group and the Sydney Users of R Forum for God knows how long, a stalwart supporter and a great authority and a great recruiter representing N-World, his organization N-World, and I'm sure there are many of you, a growing number of you here, who've had your careers changed and enhanced because you've met Greg. So if you need a job in data science, or you need a new job or a better job in data science, Greg's the man to talk to. And N-World makes this video possible. That is going to remain on the Data Science Sydney YouTube channel. In fact, Greg takes care of the channel as well. Thank you very much for that, Greg. Big thanks to the one person who has been making Data Science Sydney possible all along, and that's Fabian over there. And he's eating pizza and waving and nodding. This would not be happening without Fabian. Can't say enough good things about Fabian. It's good when he actually presents occasionally, as he does deign to do from time to time, and remind us that he's actually one of the country's foremost experts in the analytics of social networks, which is very important and rather rare skill set. And also the application of all of that in the health domain. I've probably forgotten people. I always do. Anyone else I've forgotten, thank you for helping, but you know, I've had some alcohol. The other sponsor I should mention is me, and because I haven't even been able to bring up the website for my training courses, I won't say a lot, other than to say if you want some quality data science training from me and people that I have trained, because now it's not just me, because Justin, where's Justin? Justin now teaches my introduction to R course, and Theo teaches the Python course, and there's a growing number of courses. There's Justin. If you want to get taught by us, well, have a look at the testimonials page. But the introductory data science course that I teach is, I believe, like no other, because I don't just try to teach you a bunch of steps which you blindly follow. I want to give you the intuition, the zen, the instinct for data science, and I want to give this to you in 2 days. So to teach the key concepts, to teach you why we do things, to teach you how you know when things are going wrong, to teach you when things are going right. So a lot of managers, a lot of stakeholders, a lot of people who aren't just cold-faced data scientists are doing that course to get the big picture. But it's a big picture that practitioners, I find, often like as well. So if there's one thing I'll brag about, it's the introduction to data science course. But of course we have an advanced machine learning masterclass as well, which many in this room have done. Some of you have done quite recently, in fact. But I'm really excited about the new courses we've got coming next year, and there's a heck of a lot of them. So first of all, there's going to be a fraud and anomaly course. I used to run this. There's going to be a completely revamped one, and it's going to run. There's also a forecasting and time series course. But where it gets exciting are things like a advanced machine learning, automated machine learning course, and a 2-day course just dedicated to the random forest algorithm, because the random forest algorithm can do a whole lot of stuff that's qualitatively different to just about all of the machine learning that you might have learned, and people just don't know. It's full of secret weapons. The random forest algorithm is just packed full of secret weapons, and I want to share those with you. The one I'm really excited about is a whole new direction for Prescient. We are starting courses in quantum computing. So there's going to be an introductory quantum computing course where, among other things, you will be programming an actual quantum computer. But this will lead to an advanced quantum computing course, and indeed, reconnecting back with things that I know and love, a quantum machine learning course. So all of these things are on the cards for Prescient. And if any of this interests you, come and have a chat with me during the breaks or at the end during networking. Let's introduce the main show, and let's introduce our first speaker. And our first speaker, AHMED FATTAH, is an executive analytics architect at IBM, focusing on the implementation of industry solutions that use machine learning to address strategic business problems. He has architected, led, and overseen implementations of many large-scale enterprise end-to-end analytics solutions across several industries, especially in the financial, telecommunications, and government sectors. And he has a master's degree in computer sciences machine learning from UTS. And he's going to tell us about the limits of machine learning. Is your machine learning solution viable? Very important question. Over to you, Ahmed.
Thank you. Can you hear me, guys? Okay. So, thank you, Eugene. As Eugene said, the title is the limits of machine learning, and I hope you don't think of this negative. It's I'm the most enthusiastic person about machine learning. And the aim is really to focus on using machine learning in industry, in business, okay, versus in a university or the lab, okay. So really, how you really bring it to real value from machine learning, okay. So I advise usually large enterprises how you do that, and that sometimes is not very straightforward. So it's beyond doing a model on your laptop. So I hope they will be of value to you. I know the different, I'd like actually to see a show of hands, how many people will classify themselves as a data analyst, data scientist? How many people will call themselves engineers, data engineers? On this room, only a handful. And how many will be managers who really make decisions about machine learning? Some, okay. So this is very good, good coverage, because I hope actually this will be obviously useful to you wherever you are. So the contents are very simple. I'm going to pose 3 questions and try to explore answer to them. First one is, what can we learn from the machine learning history so far? Because it's been a history, and I will show you that. And the question, which could be really very counterintuitive for a group of people who apply machine learning, is that, is machine learning suitable for any problem? Because I've heard many people, and we know machine learning is on fire now, it's very, very popular, and I've heard people say, there's no problem you cannot apply machine learning to. And it's interesting because people are very infatuated with the technology, they think it can solve all problems. So we'll explore that. And finally, say how we can create a viable machine learning solution. A viable here means ultimately it will make money, put it bluntly, okay? But it has to deliver value, okay? It's not just something I'm doing here because it's so elegant and wonderful. It's not a toy, okay? I want really to get value out of it. And I'm going to explore these questions with 3 stories. The first one is the machine learning story itself, okay? Which is a personal story, because I have been with machine learning for a while, and I went through ups and downs of the history of it. The second story is a story of a not very successful machine learning projects based on my observation. I've seen many, many projects, and a majority, unfortunately, they're not successful, they never get used. Okay? That's even worse than not successful. I will contrast this story with the story of a successful machine learning project with a sort of view to give you best practice how you do a good machine learning project. So with this, let's start. Hopefully this is not a very complex, and you don't have to read every word here. But what actually we have here is a story of machine learning driven by data. So actually what this blue line here is driven by data from a Google Ngram repository. I'm not sure if Google have scanned hundreds of thousands of books, okay? Put them in a repository, all the words in this books, put them in words in a repository, and you allow you to search by usually any term or a number of terms. That's what Ngram. And here, actually, when I searched for machine learning, I really didn't know what I'm going to get. But what I got is by putting the events of the machine learning and what actually being labeled as the AI winter, when it's the ups and downs of machine learning, where it was hot and when it was cold. It's really coincides so well. So it's really data doesn't lie. So especially in here, this is the rise here, it just was astronomical, which I was part of this period here, which was so hot. I had a job in artificial intelligence, fantastic, and then everything dropped. People start funding, people start buying or starting projects in artificial intelligence. So we could actually talk very long about this diagram, and I will really sort of try to explore it further. But really, I want really to draw your attention to this juncture here. So in here, the blue line is actual data, but the dotted line is extrapolated one. So what actually I'm telling you now, if you all literate in machine learning, if you apply an algorithm, this is data up to this point, what are you going to explore? Learn or predict. You're going to predict it's going up, but it went down. And this is my first hint of the limitations of machine learning. Now, well, people say, well, how this happened? Because actually what we're looking here is a lagging indicator. We're looking at the popularity of machine learning at that time. It's a lagging indicator. Now, I bet if we have looked at number of successful projects which deliver value, it would be going in the opposite direction, which indicates that it's gone down. So the bottom line here is I'm telling you that now I've done this up to the N-gram finished in 2008, so I had to explore it, sort of extend it beyond that. But now in 2017, well, everyone's prediction is machine learning is so hot, that's why you're all here, okay? But will it be hot next year? This is really an open question. So my message to you, multi-skill. Because next year, next 2 years, it may not be that hot. However, actually, part of the objective of this meeting is really trying what we can do to stop that. And to me, the reason we go into this ups and downs because of the hype. So this is the Gartner hype cycle. Probably some of you are familiar. So Gartner tracks the technologies and how much hype they around them. And now they have declared in 2017 that machine learning and deep learning are in the top of that. So if you cannot read this, but after the inflated expectation, which is here, you get the trough of disillusionment. They use a very poetic word. You get disappointment because something is hard. It doesn't matter how powerful is the technology, but if you set your expectations so high and don't meet it, disappointment. So that happens to many technologies. But artificial intelligence and machine learning are really peculiar. People love it. They have this infatuation with it. I want an intelligent machine. At the same time, they fear it. It's really very interesting psychological sort of phenomenon. And that's why the hype for it is so strong, okay? And disappointment is so strong. So the hype here, I've tried actually very simplistically to say the hype has producers, have consumers, and have commentator exploiters or cheerleaders and alarmists. So this actually feeds each other. And they are all the producer want really to have gains, and the consumer have maybe naivety and wishful thinking. But really my point of the whole presentation is that hype is fueled by one thing common to all the participants in the ecosystem, which is lack of understanding of the essence and limits of this technology. That fuels the whole thing. And really the counter of this is that practitioners, which you guys here, know this essence and limits, and therefore actually our duty is to educate people what can and what cannot be done with machine learning. In this case, we all have a job next year. So this is the second story of a not so very successful machine learning project. Obvious project failed for many reasons, but here I'm just finding a pattern which I see often and often. So what actually usually project starts with in an environment of hype. Okay, I've heard actually, I talked with earlier in the talk, and many people actually, I go to customers and I say, I want machine learning. Why? For what? I don't know, but I want it. But really, I hear this. I hear people feel this will solve my problem. I really don't understand it, and I don't care to understand, but I want it to solve my problem, and I have a faith. Really, that's really, it is happening. People have, because of what they read, okay, it must be true. It must be true. So no qualification if this problem can be solved with machine learning. So let's do it. And what will happen? You will end up with a standalone model done on a snapshot of data. No one understands where it came from. And success. It has high precision, high recall, everything. Wow, well, we are big success. Okay? So let's use it. And then you're faced with the next point. You have to deploy it. What data science, in data science courses, they hope Eugene teaches that, but data science courses don't teach you how you deploy a machine learning model to be used in the real world. I'm sure Eugene actually does that, but many people don't. How we integrate it? How we get actually the data? How much it costs to get the data? Because I developed the model, but the model needs the data, so I have to collect this data. In some cases, that's very expensive. It's not a trivial thing. So anyway, they cut the long story short, the project doesn't get deployed, doesn't get used. They may keep the data scientists or fire them, it depends. But that's actually, this pattern I've seen very often, and if you don't believe me, Netflix, which had $1 million prize for their model, okay, in Kaggle, and they never used the product. They never used the product of the prize. After paying $1 million, because they cited engineering cost of deploying the model is very high. So that's maybe the extreme example, but I've seen this example over and over. So what actually, I'm not sure you can read everything here. The intention is not to read it. But here is actually what the topic of the presentation to say, what's the limits of machine learning? And there are theoretical limits. I'm not getting into this different thing because my focus is really practical and commercial and economic. So when you look at actually this audience will have no problem with these limits because that's what you learn, how you do it. But at the same time, the other people who are usually consumer of this, they don't know it. And let me explain what they mean by the limits here. The limits in the technology itself, but the limits in using this technology in a given context of a problem, data, decision, certain infrastructure. This is a context. You're not applying this in a vacuum. If you sit here in a corner and do something, you may get great success, like we've seen before in a standalone. But really, in reality, this has to be used in the real world with actual problems. So the first limit in the practical sense is that we learn from data. So no data, no learning. Duh, it's a very obvious. But the point is really is not any data. The data has to be certain size. If you have only a handful, for example, not learn, it has to be balanced. If it's not balanced, your learning is not effective. It has to be trustable. You can have data but not trustable. Okay, the pedigree, where does this data come from? The data can have bias. And actually recently, I'm not sure some of you have seen this example of a headline say, is your machine learning algorithm sexist? Because they find machine learning algorithms using recruitment in certain jobs which is dominated, say, by male, they rate the female lower just because the historical data says so. The data never lie. But that's really, and this actually, somebody has in MIT have to go and do research to unsurface this bias. So we learn from data, but if we are not aware that the data can have a bias, the learning is not effective because that's not intentional and it happens in the data. And then the coverage. Sorry, the coverage of the data, it can have leading indicators which is useless. Okay, you want a leading indicator, but you can have misleading indicators. So you have indicator which is not really conducive to what you want to learn. So I don't want to go to each one of these, but the other thing machine learning uses is statistics. By definition, okay, that means you only produce probable, approximate results. So the confidence can never be 100%, and the prediction value cannot be precise, it's a range. So that's acceptable in many cases, but unless when you use it, you know that, it's not very effective. The other one is the complexity, which is makes the interpretability of the results not very full. So that probably can be seen here in our very simple example of machine learning regression. Decision trees are so interpretable. You can't explain it to a person. But when you get to the support vector machine, and as Eugene said, the random forest, which is so powerful, and now obviously deep learning is so powerful, but you don't know, it's a black box. You don't know what's inside. That's acceptable in many cases when you find it's a cat or a dog, but when you really want to do a business decision, you can't do that. You have to explain to your customer why did they refuse a loan. And then verifiability. How can you verify that this solution, in some cases, you can't do that. And that may not be acceptable in the problem you're dealing with. Finally, which is the bottom line, is the economical viability. So you can do a model which is elegant, has charts and all wonderful things, but unless it does move the needle from a business point of view. And not only do that, it has to, the payoff, which is self-uncertain, okay, it has to be higher than the cost. And people, when they think of the cost, is the cost of creating the model. This is the smallest part of the whole solution. As I said, the data collection part is the highest part. And then deploying, integrating, maintaining, monitoring the solution, then have a cost. If you don't understand all these costs, you end up with, I think, unviable. So putting graphically, or what actually I want to really tell you is that when you look at the problem, okay, think of it, there are some areas you can apply machine learning, things where you can. The different problem will be different, and it's different, I'm saying, the current limits because it's moving. So explain here, there's a number of different algorithms. We have the knowledge base, which is used a lot, but it's really cannot scale. And we have many of the other algorithms, they have plateau. So after a certain amount of data and complexity, they cannot scale, cannot get more of it. Now we have our black horse, the deep learning, it cannot perform as much as this other algorithm until you get a lot of data. It needs more, but when you give it more, it can scale. And I've heard many people who say, deep learning will never stop, but if we just give it more data, it will keep learning. No one knows that. So the current performance here, we don't know if it's going to plateau, the same as the other ones, or going to keep going, or a miracle will happen, and then a combination of things will happen where we can generate learning, intelligence free, and that perpetual machine type thing. So that's unlikely, but the point is really, we don't know. No one knows, and if somebody knows, let me know. So here is a successful project contrasted with the previous one. So what actually I'm saying, we have to first qualify the problem for machine learning. But who are going to do that? And I'm putting some roles here, but these roles can be done by one person, but they have to have these skills. So you need the domain subject matter expert. You need a data scientist, and actually now increasing, this is a new title, new role which is being actually in demand, but is not very high up and very sort of well known, is the decision scientist. Because the only value you're going to do machine learning, or do anything, okay, is to make a decision. And I'm saying this decision, how you make this decision is, well, a model will give you a prediction, but how are you going to, what are you going to do with this prediction? I have to do a decision. And that's really a whole new area, not really well understood. And then I need data engineer. I haven't seen many data engineers around, so really this is a high demand job currently. And then finally, AI architect, which is the role usually I play, which a person understands the solution at different stacks, from a decision to the data science, to the engineering, to the infrastructure, to the cloud, etc., but also across the full life cycle. So the solution doesn't stop at creating a model. It has to do a lot of other things, and it has to be maintained. Okay? So the first thing is we have to qualify the problem, assess the viability, and just to give you a hint of how you qualify a problem, it's exactly the same tree we've seen it for the limits. So you say, is this problem within the limits? Okay? So you say, do I have the data? Is the data right? Is the accuracy okay? Is the reliability, etc.? And then ultimately you do return on investment, should I expand it? Which you say, what's the payoff? Every time I use this model, I make a decision because based on this model, how much it will cost. It could be a $1, but you do that 100,000 times a day, you may actually make. So I say I can't afford to spend $500,000 creating this solution. The other things which is I'd like to highlight is the minimum viable model. So don't sit and create the gold-plated model which is outperform everything on earth. Develop a minimum viable product. Something can work, and then proceed to the next phase, which is integrated with the full solution, which has other pieces. The user has to see that, somebody has to make a decision, you have to bring the data. You have to have automated data pipeline. Many people, that could be much more expensive than everything else. Automated monitoring, you have to monitor when it's executing, does it do a good job or not? And ideally, automated retraining, because most of the machine learning models in business, at least, is using historical data. So if you use 12 months old data, and then after 3 months, you have 15 months old data, you have to keep retraining. And then you have to deploy it and monitor it, and then reiterate it. So this is my formula of good practice. So finally, I want to just recap. Say, the history of machine learning has a cycle of hype and trophic distribution. It's good for us now, we are in the hype cycle. So we're riding the wave, but don't be very disappointed if that wave will crash. Second thing is that with any technology, machine learning has its limits. And not understanding its limits, what will give you failed projects, and you may actually get the whole disillusionment with the whole industry or whole technology to a degree that you may not say to the people, you may remove data scientists from your resume next year. Then how we treat that? Software engineering, architecture, is a very proven sort of way to do good solution, has to be applied. And finally, the call for action is that the practitioner who understands things well should educate other people to say, really we need to sort of have a level-headed and understand that this technology is not limitless as it appears. Because intelligence, I can do everything with intelligence. But this is a technology. It's not intelligence. It's a technology. It can do certain things. In certain situations, it cannot do other things in other situations. So we have to be aware of that. With this, I thank you. And we have... to answer any question you may have.
Yeah, great. Thank you very much. Are there any questions? You got that half of the room. I got one here, right away.
So very early on in your presentation, you had something called the no free lunch theorem.
Yeah.
So I was just wondering what that is.
The no free lunch. I'm afraid. Okay, no free lunch, and well, above that was the induction problem. So there is a theoretical limit, okay, in what you can predict. The same as one simple way to illustrate the induction problem is that the black swan events. So whatever data you collect, okay, there will be events you cannot predict. Okay, it's a mini debate about that. But the free lunch is actually a theorem. It's a proven. Okay, I'm not going to. We don't have a whiteboard here. I could prove it for you. But anyway, that's the idea. Is that no machine learning algorithm, okay, can be transferred to other problems. So if you have two problems, okay, there will be two different algorithms which will perform the best, okay, and there's no way you can get one algorithm to be good for all problems. That's the no free lunch, which is I think it's, but it's really underneath that, without understanding in mathematics what is intuitively, okay, you say you can optimize the algorithm for one problem, okay, but if you take it to the other problem, will not be the optimum. That's the network.
Awesome. All right. Thank you so much for that presentation.
But thank you. You noticed no free lunches.
Yeah.
All right. I'm just going to jump in there. Thanks very much. Hello. Hey. Thank you very much for that presentation. It was fantastic. I was literally in a conversation today with a bunch of stakeholders, and I'm like, "How does this work?" And I'm like, "I've got 2 minutes." And it's like, "Really? How does it work?" And it's like, "Data." And then just ran out. So I'm wondering if there's like a let me Google that for you for machine learning that you just plug people at, like, they go there and like, it like walks them through the very basics. Like, is there a resource that you frequently use to try to educate people about the basics?
There are, I'm not sure off the top of my head I can give you the correct answer, but let me, I will think about it. But the point is really, these days is, somebody earlier, Gary, I think, he was saying that when he goes to his customer, he doesn't have to educate them for this, because what the media, this is the good side of the Hive, is this really, they educate the customer for us. So when we go, we use like other technology, blockchain. Blockchain is very, if you go to work, say, I'm going to give you a blockchain, so what the hell is this? Or quantum computing, okay? Well, it will take time to explain it. Artificial intelligence is very accessible. My children, okay, 12 and how old? 13 and 14, okay, they get it. If they say, what you do, artificial intelligence, no problem. they get it, okay, but I think the best, you can point them to, but they not really want to learn, okay, they want just to get a high-level definitions, okay, I have to think about it, okay, that's right.
Sorry, I'm over here.
Okay.
Thank you very much. I don't have a question, but I rather have like a personal opinion. So I've been in machine learning since 1999 and actually working in the product development. And I cannot emphasize the importance of data in life of machine learning, because your algorithm can be 85% accuracy, let's say, but if your data crap, you cannot jump higher than that.
Thank you very much. Yes.
But on the other hand, if you actually put effort in collecting enough data, correct data, your accuracy can achieve 200% improvement, 300% improvement. It's very unrare, and I'm a bit disappointed that we discuss data engineering so little in the data science community, because data science is actually a team sport. It involves many people from data engineering, databases, design, programmers, etc., etc. So we should actually stop discussing only algorithms, because algorithms are great, but there are other problems where we have to emphasize and put a lot of effort in understanding how to do it right, how to do it better.
Spot on. I'm 100% agree with you.
Yeah. So maybe that's to our organizers, put emphasis on the importance of data and data engineering in the data science meetups, because that's a super important.
Thank you very much. Yeah, that's good.
Got a question over here?
Hi, my question is, in your experience in consulting, do you find a particular industry get more value out of their project than other industry, or all of them are just about the same? I think all industry benefits, but as we said, we're really applying this, and I deal usually with large enterprise, so I will limit my observation. So large enterprise, it's really the higher profit a company will make, the more they will be able to invest in this, because it requires money. It's really real money, and it's sometimes much bigger than you think. So I would say financial industry. Okay. Financial industry is really the one spending. In particular, if you want to really extend your question in where, in customer analytics, really upsell, cross-sell, so how we better customer experience. So definitely financial sector, the retail, dealing with consumers is very, very good. Like Amazon type, anyone sell e-commerce. The telecommunication is really and they do a lot of value, but usually telecommunication has not has much money to spare. So that's but this is probably the three industries that I would say they're using most.
Yeah, I have a question here. So,
Then we can talk about that.
One over here.
okay, so Google has cloud-based app science tools,
Yeah.
and it claims that they can do for any business.
Yeah.
Now, I just wonder, is claim is a bit of an exaggerate?
No.
If such a true, then means we need app science.
Yeah, I think it's just really
Another probably topic is democratization of machine learning. Like not only Google, actually that's offered by many. I'm not going to advertise any particular company, but there's this ability to rent machine learning algorithm is very, and it will in the next few months and year will be so cheap, so ubiquitous, and you don't have to learn much about data science. Again, if you're in data science, you need to be aware of that. That can be commoditized. So you end up with, you go there, I'll try 30 algorithms for free and we'll give you the best. You don't have to think about it. But if you take the point of my presentation, it's not enough to do that. You cannot do blind machine learning. You have to understand the problem, you have to understand the data, you have to understand the prediction or output. Otherwise, it's sort of like the blind leading the blind, and you may not, actually, not only not making value, you could really make very bad decisions because you don't understand what's happening.
Okay, so for that, what you've said, the models they put online is very accurate. So the output from those models are accurate, that's enough for the manager to make a decision. Then there's no point to have another layer of the scientists there. So they say
that's what, this is increasing. Many vendors offering this, so it will be.
So is just another dimension for that science?
No. I think it's still, as I said, that you need the interpretation of the data. So it's enough. They give you the data, but in a blind way. They're not going to say for your problem. Okay. You have to use this algorithm, and you not use this feature. They're using they look the features as all equal, and one of them will predict the things. Okay, but as I said, that means in the bias situation, or how the model can be biased, but you have no idea if it's biased or not.
So basically, you say that the independence can't take their output from the model for granted. Basically,
yeah, you have to understand. You don't treat it as a black box. Look at the white box. But I'm saying actually that all the people actually, like, you don't have to create your own machine and things. You can use it in the cloud. It's very quickly, very cheap. But this understanding of the problem doesn't disappear. Still, people have to understand what's going on.
Thank you.
Yeah, you're welcome. Thank you very much.
So one quick one?
Yeah. Yeah, so my question is based on your experience doing many data science projects. I just want to know, like, in the market at the moment, like in the industry at the moment, is it is the projects of data scientists, how is the comparison between like data science as decision making and data when you implement an algorithm and integrate it with the system, like how is it more popular, or which is one is more?
I think all of them, decision scientists, I'm pretty using this term, which appears in literature, but hasn't been really very visible. And many people will think of the extension of data scientists. But to me, actually, there's a huge demand across the board. Okay, so if you're a developer and you understand how you use technology related to machine learning, if you're a data scientist, decision scientist, data engineer, AI architect, all this huge demand for across the board. Okay, but what actually matters, and this is not a mentoring session, but really you have to be. Not everyone can excel in everyone, so you have to really look at yourself and say, well, am I really can perform better in data science, or maybe better to be a developer, or better, because the demand, I think, across the board if you understand this technology. Thank you very much.